Welcome to Catalyst Method, where we ignite understanding and make learning easier. In our today's class, we'll be talking about multiple linear regression. We are still under regression analysis. The first part of the video is simple linear regression. So this is the second part. You can watch back the first video. So multiple linear regression is a statistical method that allows us to study the relationship between two or more variables. It deals with only one dependent variable, but many independent variables, such that you can be having only one y as our dependent variable, but many independent variables. You can be having x1, x2, x3 up to xn. Once you are having x, or once you are having dependent variable more than one, you will be treating multiple linear regression. Multiple linear regression can be calculated using a model. Our y, which is our dependent variable, will now be equals to beta naught plus beta 1 x1 plus beta 2 x2 up to beta n xn plus our e. This here is our estimated error. So n here is telling us that depending on the number of the independent variable that we have, in this case now we're dealing with only two independent variables, that is our x1 and x2. So rewriting the formula, we'll be having y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus our estimated error. Our estimated error can be calculated using our e will be equals to y minus y bar. Interpreting this formula, our y here is our dependent variable, our beta naught here is our intercept, our beta 1 is the slope of x1, our beta 2 is the slope of x2. And as we've already said, we said our beta naught here, which is our intercept, will tell us the value of y whenever the x is 0. Whereby our beta 1 and beta 2, which are the slope, they will tell us whether y will be increasing if x is increasing, or y will be decreasing if x is increasing. That is the positive slope and the negative slope. Positive slope tell us y is increasing as x is increasing, whereby the negative slope, the value of y will be decreasing as x is increasing. So now, how do we get to calculate our beta naught, our beta 1 and our beta 2? Because our y and x will be given to us directly from the question. So multiplied through by the summation, we'll be having summation y will be equals to, this is a constant, it will turn to n. You'll be having n beta naught plus beta 1 summation of x1 plus beta 2 summation of x2. Now from here, we can make our n beta naught subject of the formula. It will now be our n beta naught will now be equal to, move this one here, we'll be having summation of y minus beta 1 summation x1 minus beta 2 summation of x2. Then we will continue. Since it is beta naught we are looking for, not n beta naught, we will divide both sides by n. We will divide both sides by n. So dividing both sides by n, we will be having n, and divided by n. So from here, the n will cancel n, we will be left with beta naught will now be equals to summation of y divided by y will give us y bar, because that is the mean of the y variable, minus beta 1. So summation of x1 divided by n will give us x1 bar, because that is the mean of x1, minus beta 2. Summation of x2 all over n will give us x2 bar. So from here now we can calculate our beta naught using y bar minus beta 1 x bar minus beta 2 x2 bar. Now we need to calculate our beta 1 as well as our beta 2, because our y bar is very easy to calculate. That is the mean of our dependent variable, whereby the x1 bar will be the mean of the independent variable 1, and x2 bar is the mean of the independent variable 2. So we need to calculate our beta 1 and our beta 2 first to get our intercept. Our beta 1 can be calculated by using summation of x2 square into summation of x1 y minus summation of x2 x1 multiplied by summation of x2 y, all divided by summation of x2 square multiplied by summation of x1 square minus summation of x2 x1 all square. So this is the formula we can use to calculate our beta 1. Beta 2, we'll calculate our beta 2 using summation of x1 square into summation of x2y minus summation of x2 x1 multiplied by summation of x1y, all divided by summation of x2 square summation of x1 square minus summation of x2 x1 all square. We should take note that all the denominator are the same thing. The only thing that changes is this beginning. If you are dealing with beta 1, you will start with x2. If you are dealing with beta 2, you will start with x1. That is one of their major differences. And again, we should also know that we have to look for the value of our x2 directly from the table. We cannot substitute it here directly. So we have to look for the formula that we use to solve for x2 square, the formula of x1y, the formula of x2 x1, the formula of x2y, and the formula of x2 x1. We have to look for them separately. Now we begin with summation of x1 square. Our x1 square can be calculated using the formula summation of x1 square minus summation of x1 all square divided by n. Then summation of x2 square will now be equals to summation of x2 square minus summation of x2 all square divided by n. We need summation of x1 y. So summation of x1 y will now be equals to summation of x1 y minus summation of x1 multiplied by summation of y all divided by n. We still need summation of x2 y. So summation of x2y will now be equals to summation of x2y minus summation of x2 multiplied by summation of y divided by n. We also need summation of x2 x1. So our summation of x2 x1 will now be equals to summation of x2 x1 minus summation of x2 multiplied by summation of x1 divided by n. So these are what we need before we can substitute it in this formula. It's very easy, no cramming. Look at, if you are doing for x1 square, you bring the same summation of x1 square here, then minus x1 all square divided by n. The same thing for the x2 square. But for all these ones that are true to, bring the same thing here, summation of x1y, the same thing summation of x1y, then minus summation of x multiplied by the summation of y. Same here, summation of x2 multiplied by summation of y divided by n. Summation of x2 multiplied by summation of x1 divided by n. So it's very simple. This is an exercise. A researcher wants to study how hours of study x1 and number of tutorial classes attended, that is x2, affect student exam score. Why? The following data were collected from 6 students. This is our x1, this is our x2, and this is our y. x1 here is our independent variable, x2 is our independent variable, and y here is our dependent variable. We say that anywhere we are having more than 2 independent variables, we have to use multiple linear regression. Question 1. Write the general form of multiple linear regression model with two independent variables. This one is straightforward. Our equation model for two independent variables is our y will be equals to beta naught plus beta 1 x1 plus beta 2 x2, then plus our e, that is the estimated error. Now, estimate the regression equation of y on x1 and x2. Solve it in your paper. Drop the answer in the comment section. Interpret the coefficient of your x1 and x2. After solving it, interpret the coefficient of your x1 and your x2. Predict the exam score of a student who study for 7 hours and attend 3 tutorials. After solving this part here, at your final answer, since they say you predict the exam score of the student who study for 7 hours, our x1 here is our study hour. Our x1 here will turn to 7, while by the x2 will turn to 3, since x2 stands for tutorial. Please solve it and drop all your answers in the comment section. This is the end of our class on multiple linear regression. Kindly subscribe, comment, like, and share. Don't forget to turn on your notification bell so that you don't miss any new video.